If you deal with electronic circuit board assembly, you've probably noticed a trend over the last couple of decades. The miniaturization of electronic components has almost entirely done away with through-hole parts. Long gone are the days when you could pop component leads through a circuit board and solder it from the backside with your $10 Radio Shack soldering iron. Nowadays, we're talking about hot air rework, microscopes, hot plates, reflow ovens. To make matters even worse, many new chips are only offered in these very small surface mount packages. So as a hobbyist, we're sometimes forced to choose between the parts we actually want to use and the parts that we feel comfortable soldering. Luckily, the cost of equipment to do this surface mount soldering has become quite affordable, even for those of us who aren't in it for profit. There's also a wide variety of soldering tutorials available right at our fingertips, meaning that this task isn't as daunting as it once was. That said, there are still some pieces of soldering equipment where the cheap stuff is subpar and the high-end stuff is well out of financial reach. In this video, I'm going to address one such area. I'm going to build a high-precision, feature-rich, solder paste stencil printer. I'm Zach, and you're watching Zach of All Trades. Now this isn't a video on soldering, but there are several ways to solder surface mount components. Everything from simply soldering both ends with an iron, to pre-tinning all the pads, applying flux, and then reflowing the solder with a hot air pen. But for production runs, or even really large circuit boards, there's really only one way to go, and that's solder paste and a reflow oven. You simply place a precision stencil over the circuit board, apply solder paste containing flux and microscopic balls of solder, and then you squeegee it through the holes in the stencil and onto the pads of the circuit board. Next, drop the components where they go, and then you put the whole board in the oven on a very specific heating cycle. And voila, soldered parts. Let's be honest here though, this isn't quite as simple as I've made it sound. Look at some of these parts. Here's the size of a resistor or capacitor that I would regularly use, an 0402. Here's a 6-axis inertial measurement unit in a land grid array package. And here's an RGB LED where the whole thing is only 1.4 millimeters square. And if you really want to get crazy, here's a BGA part with 484 balls. These things are tiny, and this presents a real challenge. To successfully solder paste a circuit board, you need the stencil to be really well aligned, flat with the circuit board, and then you need to get a consistent amount of solder paste through all the tiny openings in the stencil. There's a lot of advice out there on how to do this, such as using spare PCBs around the one you're actually solder pasting, so you can get a nice level surface. But these are all meant for onesie-twosie jobs. There is a tool to do this, generally called a solder paste stencil printer. The simple ones basically align the stencil to the circuit board and lift it on and off. You can get cheap ones from all the usual suspects, or you can spend well into 5 figures on fancy ones. I find this unacceptable, as the cheap ones, well, they look flimsy and imprecise, and I honestly can't justify spending more than a couple $100s on this. That said, there's only one solution. Build my own. Here's what this printer needs to do. 1, it needs to hold the circuit board steady on a platform that can be easily adjusted relative to the stencil. 2, it needs to allow the stencil to repeatedly lift and then lower back down in the exact same location. And 3, it needs to hold the stencil tight down to the board. Sounds easy, right? To hold and adjust the circuit board, I'm going to base the stencil printer off of this, an XYZR precision stage. These are typically used for things like aligning optics, and they're extremely precise. This one uses micrometers that are graduated to 1/100th of a millimeter to precisely adjust all the directions. XYZR means that this not only translates in 3 directions, but it can also rotate about the vertical axis, R. This should make aligning the stencil a breeze. Now this is a 60mm diameter version of this, and I paid around $150 new on eBay, but they do make bigger ones and smaller ones. I'm not really planning to do huge boards here, so I'm sizing this to do boards about 6 inches square. I think the 60mm version will be perfectly stable for that. I can't find this exact combo, at least affordably, anymore, but if you look in the description, I've put links to the XYZ section and then separately to the R section, and they really just bolt together. To lift and lower the stencil, I'm going to 3D print a box with ball-bearing hinges that the stencil frame will rotate about. I'll then add a gas strut to hold it open and closed. Finally, to ensure that the stencil stays flat on the board, I've got a solution that really sucks. The Dirt Devil Scorpion. Actually, I'm not really sure this sucks very well at all, because despite the aggressive name, this is about the cheapest corded vacuum I could find on Amazon. I plan to just cannibalize this, just for the vacuum motor, and then throw away the rest. I do feel kind of bad doing that, but I just couldn't find a bare vacuum motor for the $30 that this entire thing cost. Regardless, I'm going to use this motor to pump down the inside of the stencil printer and pull the stencil tight to the PCB. Oh, and by the way, the files to make this yourself, as well as the bill of materials, are posted on Printables. I've put a link for this in the description. There's also a few affiliate links down there for everything I've used to make this. And with that, let's take this thing apart. A quick reminder before we get started, this thing does run off of mains voltage. So unless you know what you're doing and are comfortable working with it, don't attempt to build one of these. So now I just need to cut these labels and then find all the screws. Okay, it wasn't too hard to get this out of the housing, although they did use some pretty crappy screws. I'm going to use this circuit board, switch, motor, and everything pretty much just like it is. I'm also going to try to use this air filter, not because I need one, but because this is cool, and it's going to be like a little K&N, but for my solder paste stencil printer. Let's take these items, and let's go get them in CAD. Here's the Fusion 360 model of this. I roughly modeled up the vacuum motor, as well as the circuit board, and then everything else I'm either making or it's just off the shelf. Rather than walk you through it here though, let's 3D print these and then I'll show you the actual parts. Oh, and since everything I make needs a name, okay, let's look at the design. So this is the frame for the stencil itself. I've made this relatively thick and quite stiff, with some triangular supports, because who doesn't love triangles? This opening is about 3.5 inches square. My plan is to use a 4-inch stencil on this and just glue it into place. You'll need one of these for every stencil you're going to use, but this is a relatively small, quick print, and you can change it if you want to make this larger or smaller based on the size of your circuit board. I've made this and everything else here out of PLA for the time being, because I pretty much always print everything twice. I learned so much from the first design, and I didn't want to use anything too expensive. Next, the circuit board platform. This will just bolt to the top of the stage, and it has a little recess for the circuit board to pop into. Again, you'll need one of these for each different circuit board shape you want. Okay, now onto the main housing. The XYZR stage is going to go right here. There's a hole right here, as well as the front being open, allowing me to reach in and manipulate these when there's a stencil on top. I printed this door for the front, which just snaps into place and will help keep the vacuum in. Once you add the stencil frame to the top with a stencil in it, it's pretty much a sealed volume. The gas strut will go over here. It came with these little brackets, which I intend to use. The plan is to put the air filter back here. I've modeled roughly the same shape the original vacuum had. Speaking of the original vacuum, it's going to go back in here. You can see I printed this with these tree supports. I'm going to break these out of here shortly. I've also added this strain relief feature to help hold the cord in place. There's a little bracket which will hold onto the back of the vacuum motor. Finally, there's a door to close the back out. This will hold the vacuum motor. It has a recess for the original switch. It's got these hexagons to let air out, and also a little mouse hole to help hold the cord. This should pop right in here and screw in from the sides. Some of these parts are two-tone. There's no reason for this other than that I either ran out of a spool of filament or I didn't want to use up a whole spool. This is all just PLA at this point. Okay, I'm going to break these supports out of here. This is my first time using these tree supports. I must say, they worked quite well. If you don't have a higher end 3D printer that can do multiple materials, this could be a little difficult to print. You're going to need supports in here at least, and probably around this opening as well. It's looking like everything's fitting pretty well. I plan to hold this together with a bunch of these brass heat set inserts. So let's get those installed and then put the rest of this together. With the inserts in, let's put the rest of this together. First, I'll install a couple of these home appliance garden machinery bearings for the hinge mechanism. Only the finest. Next, I want to install the solder stencil frame using these shoulder bolts. These will go into the 1024 inserts I just installed. If you've never used shoulder bolts, they're great. I highly recommend them. They're basically a screw and a dowel pin in one, and they're great for hinges and any kind of locating feature. Next, I'll put the gas strut on. It comes with these two brackets, and I'm just using them as is. Works well. Next, I'll install the vacuum motor. This simply slides into place, and then the back gets held with a small angle bracket I printed. The first thing to do is snake the wiring through the strain relief features I've added down here. Then with that done, the motor can just be slid into place. I don't know that it really matters which way this is oriented, but you do need to make sure the wires are out of the way of the top of the motor. Oh, by the way, I believe this connector goes to some DC vacuum accessory that I neither have nor want, so I'm just going to cut these off. Okay, now install the bracket at the back with some 440 screws. And install the rear panel, popping the circuit board in as so. I tried to make this snap in, but the posts broke, so I'm just going to use some tape and I'll fix it in the next revision. Next up is putting the stage where it belongs with short 832 screws.
all I need is a stencil.
Okay, now we're at my 50-watt fiber laser engraver to cut a stencil from 0.1mm brass. I found brass is much easier to cut versus stainless. If you aren't cutting your own stencils, don't worry. Any unframed stencils from any vendor should work fine with this system. They're cheap, so it definitely is not worth the cost of buying a laser just for making stencils. This is me cutting in real time. I'm adding some pauses just to allow the stencil to cool. Then I'll do a final pass over the entire thing just to clean the surface up nicely. Now that I have a stencil made, I need to pull the top off and attach the stencils to the backside. Then I'll be able to check out how this stencil printer works. For the actual build, I'll epoxy the stencils on, but since I want to reuse this on the next revision, I'm just going to Kapton tape it for now. That should be good. The stencil isn't very tight, but with this vacuum design, that shouldn't really matter. Now to adjust this, I need to move the stage in the X and Y directions, then move it up so that the circuit board touches the bottom of the stencil. I think that's good, so nothing to do but check out how it works.
Oh yeah, one more trick up my sleeve. Rather than reaching back here and toggling the switch every time, I'm going to run the power cord through this little foot switch. So every time I step on this, they'll suck the stencil down, and I can do a board. Alright, this should just arm it. Now pushing the switch turns the vacuum on.
Okay, so one problem is that it actually sucks a little too hard. I think in the next iteration, I'll add some kind of adjustable system to control how much air is allowed to flow through. But for now, I'm just going to crack the door open a bit.
All right, let's see how well this thing works. All right, let's give this a try.
I've got some solder paste here. It's pretty old, well past its expiration. But I'll put some on here and see what happens. I'm going to squeegee this with this little plastic scraper. There are lots of tools you can use to do this, but this was laying around and is about the right size.
All right, let's see how that worked.
All right, so over here on the microscope, you can see this actually did a pretty good job. The stencil's a little misaligned. I think that's because it's actually sucking so hard it's starting to deflect the stage a little bit, which I don't have really put in there very well at the moment. All right, I'm really happy with how this prototype has turned out. So what I want to do now is go over to CAD, make just a couple of small tweaks here and there, and then I'm going to reprint the entire thing out of ESD safe filament. I made a few modifications to this before reprinting it. One thing I did was fix the size of these 4 holes so that they're correct for using inserts to mount the XYZR stage. I also honeycombed the bottom here, hoping that this might reduce the amount of warping I was getting, and perhaps also make it a little stiffer. I added a small hole here, sized for a banana plug, so I can connect this to ground to dissipate ESD. It shouldn't be needed if this is sitting on a grounded ESD mat, but this was easy enough to add. I also adjusted the tree supports in here, but this didn't work quite as planned because some of the trees failed. This didn't seem to matter too much though, as this was still fairly well supported. I can't really complain about how it turned out. I also increased the size of these bump outs, the idea being that the front would snap on more affirmatively, but it didn't really work, not sure why. This shouldn't matter though, as the vacuum pulls the door on really tight. Finally, and perhaps most importantly, I added a door over here, which is actually a separate part. When this is all the way down, the holes line up and allow air to flow right through. When pulled up, it'll totally block the holes, not allowing any air in. It can also be positioned anywhere in between to dial in the exact amount of vacuum I want inside the printer. Now I'm going to reassemble this. It's basically the same as before, so I'm going to jump through it. There are 2 extra 440 inserts though in the rear vacuum motor cover to hold the switch PCB. Okay, here you can see me epoxying the stencil into the frame. I just used a small syringe to apply a thin line around the outside of the stencil. Nothing too precise, and this should be perfectly sufficient. Finally, I used the stage to line the stencil up again. Apply some solder paste, squeegeed, and looking at the solder paste job under the microscope, I'm quite happy with it. Some of the pads are a little bit off, but this could very well be my stencil and have nothing to do with the printer. The land grid array parts look pretty decent. Again, they're discrete, fairly even blobs for each pad, even if they are slightly misaligned. I'm going to put some components on this and solder it together. Okay, with the parts loaded, I just need to put it in the oven and run the right profile. Most of this looks like it's soldered really well. There's just a questionable pin over here. Maybe due to that little misalignment with the stencil here. But overall, I'm really happy with how this turned out. That's pretty much it for this build, and I think this stencil printer has turned out really well. I'm looking forward to using it to make nearly 200 circuit boards for my tile lights project, which I've linked in the description, and you should definitely check out. That project is really going to test out the precision, repeatability, and reliability of this machine. Subscribe if you want to stay up to date and see this stencil printer in action. Okay though, to be totally honest, I'm probably going to bite the bullet and reprint the main housing to this. There are a couple of reasons why, and the first two are really dumb mistakes of mine. First, I used PLA as a support interface material for the ESD PET-G, and I didn't flush enough between the materials. This has made the layer lines at the filament changes quite weak, and a couple of them have already cracked on me, and I had to super glue them together. Second, and this one is really embarrassing, I accidentally installed 1024 inserts where I was planning to use 832 screws. For this build, I managed to just wedge 832 screws in there anyway, but this really bothers me and needs to be fixed. Other than that, one of the bearing holders back here is cracked, so I'll probably add a couple features just to make bearing insertion easier. If you found this interesting and would like to make your own stencil printer, I've put everything that I use to make this down in the description below. I've also posted the models to printables. If you do end up making one, please let me know. I would love to hear how it works out for you. That's all I've got today, so thanks for watching.